Hello and welcome to today's video. We are all used to most of our daily routines by now, such as banking, shopping, entertainment, schooling, and even working online. Now, the idea is, if I have some device that is my main connection to the civilized world, I'd like to know something about it. I want to know how to fix it if it breaks. I want to know how to add content and change it later. The wireless router in your home is an amazing piece of technology. The more you know about it and the computers on your home network, the more capable you will be in the online world. Now, in this video, we are going to discuss the basics of setting up a great home network at home. We'll discuss all the components of your home internet connection and the special languages they use to communicate with each other. If you're new to the web, once you get a brief overview of these words, you'll have a whole new perspective on how the internet works, how your home network works, or even your work network. Once you've got all of that down, we'll talk about it. Where to find all these settings on your computer. We'll then discuss how to change all of these settings on your computer in case you want to troubleshoot or make changes later. When you finish the first video, you will have a solid foundation that you can use to move on to other more interesting projects, such as setting up file sharing, setting up a NAS, setting up a VPN, accessing your home from anywhere, network printing, IP cameras. Wait. It all starts with the modem. The modem pulls in a signal from your internet service provider, which can be in the form of a coaxial cable, just like cable TV. It can be a telephone, like a DSL cable, or it can be a high-speed fiber optic cable. The modem then converts this signal into a digital Ethernet signal that the wireless router can understand. A wireless router is the most important device on your network. It's the brains of your home network. It's actually a 3-in-1 device. Routers, access points, and switches. As a router, it allows computers on your home network to communicate with computers on the internet while keeping the two separate. As an access point, it connects all wireless devices using wireless signals, allowing all devices to communicate with each other and the internet. Being a switch, it has Ethernet ports on the back that allow you to connect wired devices using Ethernet cables. Your wireless router actually acts as an intermediary between your local network and the internet. It has two connections, one on the LAN end, or one side. There is also one on the LAN side, or LAN side. The IP address on the internet side is your public IP address. This is how all computers on the internet will recognize your router. It also has a gateway address, which is how all computers on the internal network identify the router. From the perspective of the computers on the LAN, the gateway address is their gateway out of the LAN and into the internet. The gateway IP address is also the address you use to connect to and configure your wireless router. So far, we have had an internet service provider, modem, which provides the internet connection to the wireless router. We have an IP address for the public side of your wireless router and an IP address for the private or LAN side. All computers and devices on your home network also need an IP address to connect to. A single typo can cause IP address conflicts and all kinds of problems. Therefore, the geniuses responsible for the computer world invented a special protocol that dynamically or automatically configures IP addresses for all our hosts. They call it DHCP, or Dynamic Host Configuration Protocol. How it works is that when you first connect a device to a network, the first thing the device does is start looking for a DTP server. A DHCP server is a specific computer that is always running data services. Your wireless router contains a built-in date server. So when that new device thinks it's found a data server, it says, "Hey, are you a DTP server?" Then the DTP server says, "Yes, how can I help you?" The computer says, "Okay, I want an IP address." And then the GTP server says, "Okay, I have some IP addresses. Do you have a MAC address?" And the computer said, "Yes, I have a MAC address. This is my MAC address." The DTP server then stores that MAC address in a database and gives the new computer its own IP address. The same process unfolds in the same way for all other devices on your home network. Now, if you take a closer look at the IP addresses on all the computers in your home network and the IP addresses on your wireless router, you'll notice that they look almost identical. The first three parts, or what we call the octets, are the same. The reason is how computers recognize and communicate with other devices on the network. So if the number here is 1, this computer cannot communicate with other computers because they are on different networks. The only way a computer can communicate with computers on a different network is by using a router. This is what your router does. It separates your home network from the internet. It does this through a complex protocol called NAT, or network address. Well, what it does is allow computers on your home network to communicate with computers on the internet without exposing your home computer to the hazards of the internet. Now, a simple way to extend the wired side of your home network is to use a switch. A switch is a very cheap, easy-to-use device. However, people can get carried away by these things. A lot of people will start daisy-chaining them and run into problems. The electronics in these devices aren't sophisticated enough to keep track of all the hops from switch to router, to computer, to this to that. They just don't have the ability to do it. Sometimes this may work. Other times not so much. So if you start trying to daisy-chain switches, you're likely to end up with a very frustrating, unreliable network. The last item is the most important one. Without it, all computers on the internet would be lost. It's called DNS, or Domain Name System. Now what DNS does is match all human-readable domain names with computer-readable IP addresses. It's a lot like the address book on your phone. If you're hungry and want to order some burgers, you probably don't even remember the phone number of the takeaway place. But you just find it in your address book, dial the number on your phone, and 30 minutes later you have your burgers at your doorstep. DNS works basically the same way, just faster. You simply enter the address of your favorite website. Your computer has no idea what the website's IP address is. But DNS servers can. So what your computer does is looks up where to find its DNS servers and asks, "Hey, DNS, where is wifigi.net?" The DNS server said, "Well, that sounds familiar. Let me double check." Oh, and the IP address of wifigi.net is 12.45.212.76. The amazing thing about DNS is that not all DNS servers know the location of all IP addresses and domains. So if it doesn't know it, it will forward your request to another DNS server on the internet. Indeed. This is how the internet gives you literally the entire world to yourself. The deeper you look into computer networks, the more you see them and the more it makes sense to you. Before long, you'll be able to troubleshoot computer network problems with ease. Now any questions you have about how to set up a computer on your network can be answered with a simple command. This is called IP configuration. IP configuration is not an icon on a menu. It's kind of hidden. But once you know how to implement it, it's easy. So let's take a look now. In this section, we'll take a closer look at the IP configuration commands. That's it. In fact, we have to do more than just look at it. We are going to look at what this command can actually do for us and what it can actually tell us about our computer network connection. So, to get into the command prompt, you need to type cmd here to search for the command. The prompt window opens in the wrong screen. Once the command prompt window opens, just type itconfig. You don't have all these things that I do on the computer. I have a lot of weird connections on my computer. So basically what we are looking for is an Ethernet adapter. We can see our IP address as a subnet mask. We don't care about this. Then there is the default gateway, which is the wireless router. And our internet gateway, so where is the rest? When you enter only the IP configuration, you don't get the full information. What you do is add a little switch, which is /ALL. Then we got all the information we were looking for. Okay, let's go back to the 192.168.1.3 IP address. There is also the default gateway, which is the wireless router, DHB server. This is how we get our IP address. In addition, there are wireless routers and DNS servers. Through all this, we know the basic status of this computer. This is an IPv4 address. When we get into the troubleshooting section, I'll show you how to make changes based on your connection status. If you are not connected, this number will be different. If you have a connection, but it's a dead link, it will look like something else. So just doing the IP configuration gives you a lot of information about how your computer is connected and what it's connected to. The one to look at now is the physical address. You've got all these numbers and letters here. This may seem like something that most people just want to ignore, but in fact, it's very important. The physical address is the MAC address. If you remember, when the device first connected to the network, it asked the server for an IP address, and the server said, "Okay, but you need to give me a MAC address. So that's the physical address now. What is a MAC address? It's a series of letters and numbers. It's a code that's embedded into the hardware of all devices that have a network connection. So whether it's a computer, printer, laptop, phone, or any device with a network connection, even wireless devices, there is a MAC address. So this is an important thing to note and it will come in handy later. Now, let's go back to the command prompt. While we're here, there are a few things I'd like to see here. Now I tell you how this changes. According to the connection status. Another way to test a connection, which we'll go over in detail in the troubleshooting section, is basically a method called ping, which throws a packet at the device. If the device replies, that means it's already open there. Let's test it out. Let's test using the default gateway, which is also the wireless router. So you go down, here you ping, and we are going to try the default gateway, 192.168.1.1. If everything is fine, you'll get 4 responses, and then it'll give you some more stats on whether they all succeeded and everything is fine. Okay, so that's some of the things we'll discuss in detail in the troubleshooting section. But that's basically it. This is the IP configuration, where you can view the network connections on your computer. Things are always changing, and sooner or later you're going to have to make changes, big or small, to your home network. So what are the reasons you might find yourself wanting to change your computer network setup? An obvious situation is when you discover a problem with your network and after some troubleshooting you realize that some changes need to be made. Another scenario might be that you took your computer off another network and need to put it on your network. You must change the settings on this computer to make it work on your network. In this case, we will make some small changes to one computer, which will increase the functionality of the entire network. You want to remotely control a specific computer from any other computer on the network. Let me give you a quick overview of how VNC works. This is a free program that allows you to control other computers on your home network. If you have a main computer in your living room and you want to control it from your upstairs bedroom, you can do this using a free program called TypeVNC. With TypeVNC, just launch it and enter the IP address of the computer you want to access remotely. Click Connect. Enter your password and you have complete control over this computer from another computer, just like you would if you were sitting in your living room. The main issue you need to worry about is whether you want to use the IP address to access the remote computer if you are working with data. Yes, the IP address may change and running downstairs can be a bit of a hassle. Seeing what the new IP address is and then running back upstairs defeats the purpose of the whole thing. Therefore, you can use a static IP address on one computer so that it never changes. What we want to do is change the date, keep it set to static, and then put a static IP address on that computer that we can run on. Let's just pretend that this computer is that computer. To make changes to this computer, all we have to do is go to the network adapter or Ethernet adapter settings for that computer. So we went back to where we had been before. Instead of entering CMD, we enter Ethernet and then go to Ethernet settings. When it comes to changing network settings on your computer, this is basically where you want to go. In this case, we will make changes to the adapter settings. We will assign a specific IP address to this network card. You need to change the doctor options and then you will see all the different network connections you have on your computer. You will see the Wi-Fi connection, you will see another Wi-Fi connection. Assume you have a new ISP network connection. I have a NordVPN, so here, it is in case I want to use it. Okay, I also run Hyper-V, which is a virtual machine. If this is the case, you will have a network connection. So we're not interested in everything about this particular one. We're interested in the Ethernet connection here. You just highlight it and we invoke all of your mouse's powerful right-click capabilities. Now we can look at all these little things here. Now if you wish, you can click disable and now the computer no longer has a network connection. You can just right-click on it and enable what we want to focus on. Mostly status and property. If you click on the status, it displays all kinds of interesting information and statistics about that particular connection. If you look down here, whenever you see the movement here, you can see a display of the actual packets sent and received by the network card. You know something is working fine. What do you get if you click on details? The information you get is almost identical to what you get from the IP configuration at the command prompt. In our case, what we want to do is remove the attribute. Properties are where all the cool stuff is. In this case, we really don't want to get involved in all the other stuff. We want to focus on Internet Protocol version 4, highlight it and go to Properties. Now we have a place to actually change the IP savings on this network card. So now it is set to obtain the IP address manually and obtain the DMS server address automatically. If we want to say, we want a specific IP address on this computer, we just use the following IP address. Let's say we want to name this network card 15. So we just type in 192.168.1.15, click here and it will automatically fill in the subnet mask. Subnet masking is a very in-depth topic that you don't really have to cover too much on your home network. What is the default gateway? We already know that. That would be a wireless router, 192.168.1.1. Then you go into the details and it's just like doing IP configuration. Your IP address has been changed to 15. Now this is just for demonstration purposes. So let's circle back to the ATP. So it's sent back to ATP. Go back to Internet Protocols, go to Properties and just click on the protocol to delete everything. Just put it back and it's like, hey DHCP server, do you remember my DHCP address? The DTP server will say, yes, no problem. Don't worry. It's still free. So when you pay attention to the details, boom, you're still back to tree. The way it works is called leasing, which means ATP will remember your IP address for you for one day. That's it for the basics of changing network settings on your computer. That's it for today's video. Thank you for watching. Bye.